Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about solving absolute value equations. In this video, we're going to talk about the absolute value basics. Then we're going to solve with multiplication. We have a temperature tolerance problem. We have a weight tolerance constraint problem. And lastly, we'll be determining viable range. And so, when you're ready, let's get started. In this problem here, we want to solve for x. We have the absolute value of x minus 3 is equal to 7. Let's solve this equation. We have two cases here with this absolute value. Since it's absolute value by itself now on one side of the equation, what we can do is rewrite this as x minus 3 equals a positive 7, and then an x minus 3 equals a negative 7. And now we have to solve each one individually. First one here, I'm going to add a 3 to both sides of the equation, and x equals 7 plus 3, which is a 10. Here, same idea. I'm going to add a 3 to both sides of the equation. X is now by itself, and negative 7 plus 3 is a negative 4. And so we have two values for x. X equals a negative 4 and a positive 10. And so our solutions here are x equals negative 4 and a positive 10. Now let's solve for x with this multiplication type problem. We have the absolute value of 2x plus 5, and that's equal to 9. Okay, since we have the absolute value by itself on one side of the equation, we can separate this into two different equations to solve. We take the inside, the 2x plus 5, and we set it equal to a positive 9. Then we rewrite this, 2x plus 5, and we set it equal to a negative 9, the opposite there. And now we want to solve each one of these individually. First step here, I subtract a 5 to both sides of the equation, and we have a 2x's left is equal to 9 minus 5, which is a 4. Then divide by 2 to both sides of the equation, and x equals 4 divided by 2, which is a 2. Here, we subtract a 5, again to both sides of the equation. 2x is equal to negative 9 minus 5, which is a negative 14. Now from here, I'm still dividing by 2 to both sides of the equation. They cancel, and we have x by itself is equal to negative 14 over 2, which is a negative 7. And so my two answers here for x are negative 7 and a positive 2. So we solved our equation for x, and we got x equals a negative 7 and a positive 2. A thermostat is set to 70 degrees Fahrenheit with a plus or minus 3 degree Fahrenheit tolerance. Write and solve an equation for the temperature range. Okay, let's let x be the temperature any temperature that this thermostat can be set at. We know when we subtract 70 from that, and we take the absolute value of that subtraction, that's going to give us that 3 range. Now it's plus or minus, but we know when we separate this, we're going to have that plus or minus there. And so this is how we can kind of set up our absolute value equation. We have the absolute value of the values that x can be minus the set point, 70 degrees, and that's going to be equal to 3. So now solving this, we want to separate this into two different equations because we already have the absolute value by itself. So we have x minus 70 here is equal to a positive 3, and x minus 70 is equal to a negative 3. And now we want to solve for x. So we're going to add a 70 to both sides of the equation, and x equals 3 plus 70, which is a 73. From here, same idea. We add 70 to both sides of the equation, and x equals a negative 3 plus 70, which is a 67. And so the range of values that x can be, the temperature we can set, is 67 degrees Fahrenheit, is less than or equal to x, which is less than or equal to the values in between these two degrees, 73 degrees Fahrenheit. It can equal those endpoint values and any value in between. That's what we can set up here, that temperature range. So the temperature range here for the thermostat is 67 degrees Fahrenheit to 73 degrees Fahrenheit. A bag of flour should weigh 5 kilograms with plus or minus 0.2 kilograms tolerance. Write and solve an equation that models this. Okay, let's let x represent the values of the weight that the flour can be. And if we subtract 5 from that, we should get a 0.2 tolerance, okay, within there. So we're going to set up the ranges, the endpoints of this. If we put the absolute value of this, we can put a 0.2 right there. And we know when we solve this, we're going to separate this out to a plus and a minus. And so now we have an equation here that can set up here finding those little endpoints of the tolerance range. So solving this, I'm going to set each part here, this x minus 5 equal to positive and negative 0.2 individually. So if x minus 5 is equal to a positive 0.2, and x minus 5 is equal to a negative 0.2. Now I want to solve for x. I'm going to add a 5 to both sides. And x equals 0.2 plus 5, which is a 5.2. Then from here, same idea, I'm going to add a 5 to both sides of the equation. And x equals a negative 0.2 plus 5, which is a positive 4.8 here. And so we can set up our range. Our lower range is a 4.8. That's going to be kilograms. Is less than or equal to x. The value, the value that the flour can weigh, is less than or equal to the upper range, which is a 5.2 kilograms. And so we had an equation that models our scenario here. We got absolute value of x minus 5 is equal to 0.2. And we have solved this. We found all the values that x can be that are within this range. And that's 4.8 kilograms is less than or equal to x, which is less than or equal to 5.2 kilograms. A car's fuel gauge shows 10 gallons, but it may vary by plus or minus 1.5 gallons. Write and solve an equation. Okay. Let's let x represent the amount of fuel that can be in the car. If we subtract 10 gallons, this should tell us here, which should be within that range of plus or minus 1.5. So to show that, we're going to put an absolute value here around the x minus 10, and that's equal to a positive 1.5. The plus or minus will happen when we separate this and solve each one individually. We now have an equation, so let's solve this. We take the x minus 10 equals a positive 1.5, and x minus 10 is equal to a negative 1.5. Now from here, we're solving for x. Left side first. We add a 10 to both sides of the equation, and x equals 1.5 plus 10, which is 11.5. On the right, we're going to add a 10 to both sides of the equation here, and x equals a negative 1.5 plus 10, which is a positive 8.5. So we can represent this as a range for being 8.5 gallons is less than or equal to x, which is less than or equal to 11.5 gallons. And this tells us the range of values for the gallons that could be in the car that are still within our acceptable tolerance here. So again, our equation, absolute value of x minus 10 is equal to 1.5, and our range of values solving this is 8.5 gallons is less than or equal to x, which is less than or equal to 11.5 gallons. Now let's review what we've covered. We first had a problem that was absolute value basics. Then we solved with multiplication. We had a temperature tolerance problem. We then had a weight tolerance constraint problem. And lastly, we were determining viable range for gallons in a car trip. I now leave you with this bonus problem. We're talking about the maximum height for a ride. The maximum height is 150 centimeters with a plus or minus 3 centimeters tolerance. Write and solve an equation that models this scenario. I hope you learned something here on solving absolute value equations. And as always, thanks for watching.